All right, so sequences are just a list of numbers with a pattern. A sub 1 means it's the first term of the sequence. A sub 2, these are subscripts, would be the second term. If I write A with a little n, I read that A sub n, but that's just the general formula for a sequence that we're going to use. So that's A sub n, which means the nth term. But we describe our sequence, a lot of them, for their formula as just A sub n, because we could plug any number in that we want. And then one more thing that we see a whole bunch is A sub n minus 1. And that just means the term that came right before the one that we're thinking about. Like if I was talking about the fourth term, A sub 4 minus 1, what is 4 minus 1? 4 minus 1 is 3, right? So if I was talking about the fourth term, that would be n minus 1, that would be the third term. 3 is the term that comes before 4. If I was talking about the fifth term, 5 minus 1 would be 4 is the term that comes right before. So when I see A sub n minus 1, I just think of that as the term right before. If it were n minus 2, that would be 2 terms before it. N minus 3 would be 3 terms before it. N plus 1 would be 1 after. Does that kind of make sense? Whichever one we're looking at. If you're subtracting, that's going backwards. Adding, that's going forwards. So those are just important things that we need to know about sequences before we start working some problems out. So we're going to find terms in sequences. We're going to use formulas to develop a sequence. And there's 2 types of those that we're going to look at. And then we're going to take a sequence and write it in a formula. So someone would be able to find like the 100th term without having to count. Okay, because wouldn't that be nice if I had a formula for this? And if someone said find the 100th term, you don't have to do whatever they're doing 100 times. You could just plug a number in. That's what we're going to do. Does anybody think they got our first sequence if you figured out what the pattern is? Anyone want to put in the chat what the next term is you think it is? What's coming next? Yeah, it's 970. So we see what's happening in between these numbers. I might not be really clear here because I'm going from a negative to a positive, but I'll just look at the others and see if I see a pattern. From 170 to 370, I'm adding 200, right? 370 to 570, I'm adding 200. I'm adding 200. So is there a pattern here that we see that's happening every time? Yep, we're going to add 200. So the next one would be 970. That's our next term. So that's 1, 2, 3, 4, 5. This is our 6th term. So A sub 6 is 970. 970 plus 200 is 1170. And then plus 200 is 1370. You could just write 970, 1170, and 1370. I just wanted to show you how we would write it using the notation. This was term 1, 2, 3, 4, 5. So that one's the 6th term, the 7th term, the 8th term. Anybody think they know what the next number is going to be in the sequence for number 2? Anyone see a pattern there?
It gains a number each time.
Right, what you're adding?
Yeah.
So what do you think the next one's going to be? So between these 2, we added 2, right? Then we added 3. Then we added 4. Then we added 5. And so how much are we going to add 25. For the next one? We're going to add 6. So that's going to be 25. Then we're going to add 7. So that'll be 32. Then we'll add, how many comes next? What are we going to add next? 8. And 32 plus 8, that's going to make 40. I'm going to have to get my calculator out for the next one. So occasionally we're adding the same number. Sometimes we're adding a pattern. You see how that's a pattern in itself, that you're adding 2, 3, 4, 5, 6, 7, 8. On number 3, I don't know that we're going to do any adding patterns here, because that's a plus 4, then minus a 12, and then plus 36, and then minus a whole bunch. Is there another something that's going on number 3? Anybody notice something? I just saw somebody mouth multiply. What are we multiplying each of these numbers by? 3. We know we have a 3, but we're switching from negative to positive, so we're multiplying by negative 3. So negative 1 times negative 3 is 3. 3 times negative 3 is negative 9. Negative 9 times negative 3 is 27. That looks like x minus 3. These are like times. So we're going to do times 3 to get our next 3 numbers. So negative 81 times, not the regular 3, negative, sorry. Negative 81 times negative 3 is 243. Do it again. Negative 729. And then 2187. So this was an addition, but it changed, and this one's a multiplication. So if you can't find it with addition, then think maybe they're multiplying or maybe they're dividing for that. Any questions on finding the next terms in the sequence? Thumbs up if you feel okay with that. Okay. There are 2 types of formulas that we can use. We have explicit and recursive, and explicit isn't like what they write on your music songs, that if you shouldn't be listening to them if you're under a certain age. Explicit just means that we can plug a number in, any number, and that's going to give us that number for that specific term. So we don't need to know anything else except the term number we want, and we'll be able to find our formula. So our explicit formulas. To find the numbers, you're just going to plug in whatever term number you have. An explicit formula would look something like a sub n equals 3n plus 5. And if I wanted to find the first term, I would just plug in 1 for n. If I wanted to find the 7th term, I would plug in 7 for n. Okay, we'll do some of those in a second. We have explicit formulas coming up. And recursive formulas, they state the first term, do y'all remember our notation for first term? A sub 1. So they state the first term, which is a sub 1. And then after that, they describe how to get from the first term to the next term, to the next term, to the next term. So this first one's an example of an explicit formula. The second one would be an example of a recursive formula. They tell you the first term, like say it was 7, then they tell you what happens after that. So I'll show you how to read through and make sense of this part, okay? So on a recursive formula, they state the first term. So in this example, our first term was 7, okay? Now this is saying all the rest of our terms, or anything that comes after that, is, what did we say a sub n minus 1 was? The term that came before, right? So to get your next term, you take the term before and you're adding 4 to it. So if my first term was 7, to get my second term, I take the term that came before, which was 7, and I add 4 to it. So what should I get? 7 plus 4 is 11. Now to get my next one, I take the one that came before and I add 4 to it. So what's my next term going to be? 15. Okay. What's my next one going to be? I want the one that came right before it, plus 4, and that makes 19, etc. So what this means is just you start here, that's my first one, and then after that, to get the other terms, I take the one that came right before, and then I add whatever number's there, or it might be a multiply or a divide or something. It tells you what to do to get to the next one, okay? So it's kind of like a way to write up what we were just saying here. I start with -1 and then I multiply by -3. Explicit isn't quite so straightforward in that. You're just plugging the number in and getting an answer. So we're going to do some explicit sequences first, and then I'll have y'all work on some recursive ones. So when they just give you a formula like this and they want you to find the terms, you're simply plugging in the term number you're on. So I'm going to do the first 4 terms. So I want to do a sub 1, a sub 2, a sub 3, and a sub 4. So to find my first term, I'm just going to plug in 1 for the n. It's just like evaluating a function. So -205 plus 200 times 1. And that's -5, right? And our second one, what are we going to plug in for n if we want the second term? 2. So -205 plus 200 times 2. And what's that going to be? 195? I think so. What do you plug in for the next one? 3. That's 395. And then at this point, you could probably see a pattern over on this side. It'll probably be able to just kind of see what it is without having to type this into the calculator. -205, but I'll make sure I'm right, plus 200 times 4. That is 595. So when you are writing out the first however many terms of a sequence and you're given an explicit formula, this is explicit, it's just the one equation, you just plug whatever term number you want in for the n. Any questions on that? So you're just evaluating for 1, 2, 3, and 4. Thumbs up if you're good. Okay, I got 4 thumbs up, so at least 4 of you guys are good. Okay, go ahead and let's try number 5. I'm going to have you guys work this out. So if you don't have a calculator, you might need to use your phone calculator, or you can use Desmos if you want to. So we want to find the first 4 terms of our sequence. A sub 1, A sub 2, A sub 3, A sub 4. So I'll get you started on the first one. First term means we plug a 1 in for n. 10 to the first plus 3. Then you'll do 10 to the second plus 3, then 10 to the third on your equations. So go ahead and fill that out and get your answers, and we'll check and make sure everybody got all of those. When you think you got it, hit the raise hand button. When you've done all 4. All right. Jayla and Layla have raised hands, and it rhymed. Mackenzie and Shalia have raised hands. It didn't rhyme. Come on, Donovan. Jackson. All right, on your mark, get set, type your answer in the chat. Go, go, so fast. Write your 4 numbers separated by a comma. So just 1, 2, 3, 4 like that. Answers are looking great. I'll make sure that we have this all set up correctly. Okay, so good job. I think everybody got all those right. Awesome. 10 to the first plus 3 is 13. 10 to the second plus 3 is 103. Then 1,003. And then 10,003. You could guess what the next number is without even having to plug it in, right? It would be 1 and then how many zeros? 4 zeros and then a 3. Then 1 and 5 zeros and then a 3. Okay. You can see that we're adding a 0 in between there each time. Any questions on explicit formulas? So these are the explicit kind. You just plug the number in, get it for each term. Okay. These take the most writing when you're writing out all of your formulas, but I do want to see you writing that down when you're working your problems out. 7 and 8 are not explicit formulas because they give us our first term and then they tell us what to do after that. So if we, not 7 and 8, sorry, 6 and 7. So if we notice on number 6, what is going to be the first term in our sequence on number 6? You can just mouth it. 16. Yeah, the negative 16 is our first term. So we know that's our first term. How are we going to get to our second term? What's going to happen in between all of our numbers? To get the rest of our numbers, we do the one that came before plus 9. Okay, so negative 16 is our first term. Then to get to our other terms, you're going to add 9 each time. So negative 16, that's the first term. Oops, I didn't write 2 T's. First term. And our change, this is our change. We're going to add 9 each time. Okay, so to get to our second term, we do the one that came before, which would be our first term, plus 9. Then we do all of that. So we can go ahead and list these out. First term is negative 16. I'm going to list them just like we did up above. So I'm going to say add 9, negative 16 plus 9. That is negative 7. And I'm just adding 9 in between all of my problems. It tells me here what I'm going to do. I'm going to add 9 each time. So negative 7 plus 9 is 2. And 2 plus 9 is 11. So most of this is just recognizing what the notation is telling you to do. Is everybody good with it telling us that that's our first term? A sub 1 is this. That's where we start. And then after, this little number here is just telling us what's happening after the term that came before. So A sub n minus 1 just means the one that came before plus whatever that is. This one plus that gives us this term. Plus that gives us that term. Okay. So let's look at number 7. Where are we going to start? Where's our beginning number?
4.
Our beginning number is 4. So that's our first term. We know that's where we're starting. And what is our change in between our numbers?
Times 5.
Times 5. So that's what we're going to do every single time. So I want you guys to write out your first 4 terms. You start with 4, and then we're going to say times 5 each time. All right, who thinks they got it? You've written them all down. Good. Okay, if you think you got it, go ahead and put those 4 terms in the chat. Awesome. So we did times 5 each time. So 4, 20, 100, and 500. So the amount of work that I'm showing on my page is the amount of work that I want you guys to show on your paper. Some of it you could probably look and do it in your head, but I do want to see that you know that you're starting here and what you have to do each time between them. Okay. And the last set of problems we're going to do is they're going to give us the list of numbers, and we're going to either write the explicit formula or the recursive formula, depending on what they ask us to do. I like to write recursive formulas better than explicit because they're a little bit easier to figure out. But y'all got this written down, ready for me to go to the next page? Okay, so on number 8 and 9, we are writing recursive formulas. That's where we have to put the first term and the change. And the other ones will do the explicit, where it's just an equation. So on number 8, we need the first term. So since it's recursive, we have to put this, and then we have to do this with the change. So all we have to fill in is what the first term is and what the change is. So we have to figure that part out. What is our first term on number 8? -1. Yeah, it's just the beginning term. Good. And what's happening in between these numbers? Anybody see the change in between the numbers? What's the pattern? Multiply by 5. Good. So our second part of our recursive formula is a sub n. All of our terms are the term that came before it times 5. I want you guys to try number 9. So we fill in the first term, then we're going to fill in the change. Are you adding, subtracting, multiplying, dividing, and whatever number it is? All right, raise your hand if you think you got it. Good, good. And if you do, go ahead and in the chat, put whatever you put in the first blank and then a comma and whatever you put in the second blank. Good. Awesome. So y'all got that our first term was 12 and our second term was, in our change, what happens in between them is a plus 8. So to get a term, you have to have the one that came before, then you had to add 8 to it. Is this method or in the recursive formula a good method to use if you had to find like the 99th term? Would you want to use this to find the 99th term? Because you would have to do it like 98 times, right? And add 8 and add 8 and add 8 and add 8, and that wouldn't really be fun to do. Recursive is good if you're just trying to do numbers like at the beginning to get the sequence started. But if you're asked to do like a term way far in the distance, you want an explicit formula if possible. Because all you have to do, if they say find the 99th term, you just have to put 99 in for n. But if I did that here, that would say to find the 99th term, I need the one that came before, which was the 98th plus 8. But to get the 98th, I need the 97th. To get the 97th, I need the 96th, you know, et cetera, et cetera. So you don't like to use recursive if it's way far in the distance. You want to use explicit for that instead. Okay? So let's see if we can figure out some explicit formulas. These take a little bit more of guess and check for it and to see kind of what the pattern is between them. So first I want to see what we got going on. I'm going to write the term number underneath because if I plug a 1 into the formula I'm going to get a 39. If I plug in 2, I need to get 45. If I plug in 3, I need to get 51. Okay, so these are the term numbers. I'm just putting them underneath. Nothing jumps out right at the beginning, does it? If I'm putting a formula for 1, if nothing is like really clear, if it's not multiplying by the same thing each time, I want you to see if you can figure out what the pattern is in between them. It looks like we're adding 6 each time, right? If you are adding 6 each time, you're going to have a 6 in the problem. If you're adding 5, you're going to have a 5 in the problem. So whatever you're adding is kind of like your slope. You know, you think about your mx plus b if you're adding that each time. So in our problem, we know we need to have a 6 in because we're adding 6 each time. And we just have to figure out this number. So let's see. If I'm going to plug 1 into my equation, I need to get a 39 out of it, right? First term is going to give me 39. So let's see. 6 times 1 is 6, right? Plus what gives me 39? I'm just going to solve for it. So a sub 1 is going to be 6 times 1 plus something has to give me 39. So 6 plus what is 39? 33? Yeah. So we just used our reasoning skills. We'll see if it works for the rest of them. A sub 2 is 6 times 2. We're going to try 33 again. We think that might work. That's 12 plus 33, and that makes 45. Does that check with what we wanted? Yep. So our equation is 6n plus 33. So if you're adding 6 each time, you're going to have a 6n in the equation, and you have to figure out what you have to add to it or subtract. You might be subtracting to get what you needed on each term. A neat trick for these that always works with the linear ones, which these are linear, you're adding the same each time, is if I had a 0 term, like say what term would have come right before 39? If there was a term before 39, what would it have been? So think about these. These are going, it would have been 33, right? Whatever term would have been right before it is what's going to go in your blank. That happens every single time for these. So you can think about what would the 0 term be if there was such a 0 term, the one that came right before. That's going to go in the blank. It always ends up being that number. Okay. All right. Now let's look at number 11. We need a first term, second, third, fourth, fifth. So when I plug 1 in, I'm going to get 2. 2 in, I'm going to get 5. 3, I'm going to get 10. 4, I'm going to get 17. And 5, I'm going to get 26. Do we have a pattern in between these? That's a plus 3, a plus 5, a plus 7, a plus 9. Are those the same number? There's kind of a neat trick that happens. If I went one more step above this and saw what happened in between these two, to get from 3 to 5, I added 2, right? Added 2, added 2. Are these the same number? If it happens on the second row, here I had 6n. I just had n to the first power because it happened the first time. This time, since it happens on the second row, I'm going to have an n squared in my answer somewhere because that was the first, second row that happened. If it happened the third time, it was a cube. And we'll have more stuff on these. It'll be more straightforward in the next lesson. This is just kind of getting us to think about it. So if the numbers match on the second row, you have an n squared. So they're not the same here, but they are if I kept going. I'm going to have an n squared in the problem. So now I just have to figure out what gets added or multiplied by that n squared. Sorry, that's my general one. Let's do a plus. Plus something. So I'm going to try 1. 1 squared plus something is going to give me 2. 2 squared plus something is going to give me 5. Can anyone see what's going to go into our blank space? Go ahead and hold up your number that you think. It's going to be 1, right? Because 1 squared is 1, plus 1 makes 2. 2 squared is 4, plus 1 makes 5. If you do it again, 3 squared is 9, plus 1 is 10. 4 squared is 16, plus 1 is 17. Okay, so for these, if you get stuck, remember you do have multiple choice options to look at, kind of help you with it. So ours is a sub n squared plus 1.
So, like, can you go backwards from the first number and get your answer like the one above?
Yeah. So if you went down, what would it be? Going down 1 unit, right? Because that would have been 7, 9, 7, 5, 3, add 1 in between. So add 1 would have given you a 1 there, right? Yep, you can go backwards and do it with those two.